Continuing from previous lesson, we will do few more questions for better concept of slope. Let's get started with question number 1, in which there are 4 points given on the grid labeled as A, B, C and D. And what is required of us, we will find slope of line AB and slope of line CD. Let's write down coordinates of point A, which is 5 units to the left of y-axis and 3 units above the x-axis. Therefore, its coordinates would be -5 and 3. -5 because it's 5 units to the left of y-axis and +3 because it's 3 units above the x-axis. Similarly, coordinates of B would be -1 and 6 because it's 1 unit to the left of y-axis and 6 units above the x-axis. And coordinates of C would be 1, 2, both positive, because C is 1 unit to the right of y-axis and 2 units above the x-axis. That's why both of the coordinates mean abscissa and ordinate will be both positive. And coordinates of D are 4, 4. If we want to find slope of line AB, let's call A as x1, y1, x1, y1, and B as x2, y2. Then, how much change has occurred while going from point A to point B? The change in x has been x2 minus x1. So change in x is equal to x2 minus x1, and change in y is equal to change in y. How much y has changed? That is equal to y2 minus y1. Change in x is mostly denoted by delta x. Delta x, this is equal to x2 minus x1, and change in y is similarly denoted by delta y, which is equal to y2 minus y1. Now we have formula for slope m, which is equal to delta y over delta x, is in fact equal to y2 minus y1 over x2 minus x1. So if you are given coordinates, you can just substitute the values and get the answer. For y2 minus y1, how much y has changed? The y has changed from 3 to 6. So this would be 6 minus 3 divided by how much x has changed, that is from -5 to -1. So -1 minus -5. This is how much x has changed. Therefore, this would be 3 over 4, and this is called slope of line AB. Let's call this M, and this as M as well. So this is how you can find slope of line AB. If AB are given points on the grid, you can write the coordinates and then use those values of coordinates as x1, y1 and as x2, y2. For point B, we have for point CD, the C is given as 4, 4, 4, 4, and D is given as 1, 2, 1, 2. If these are the points, then let's call this as x1, y1, and call this as x2, y2, and slope is equal to y2 minus y1 over x2 minus x1, and we can write down the value of this equal to 2 minus 4, 2 minus 4 divided by 1 minus 4, 1 minus 4. So this would be equal to minus 2 over minus 3. So ultimately the slope will become 2 over 3. This is m, this is m, and this is m. This is how you can find slope of any line. So this is slope of line CD. Slope of line C and D. Now next question is that we are required to draw a line with slope minus 3 and denominator is 7. So question number 2 here. For that purpose, let's draw the grid here. And for this grid, we are given slope m is equal to minus 3 over 7. This negative sign in front of this fraction should either go to the numerator or it should go to the denominator. Let's take it to the numerator. If that is the case, then we take this minus 3 over 7, and if you write it equal to rise over run, the definition of slope, that's fine. If you write it as delta y over delta x, that's fine too, because delta y would be the change in y. If it is positive, that change will be upward. If it is negative, the change will be downward. And the denominator will be positive if the change is positive, and we'll move toward right. If it was negative, then we'll move toward left. As there is no point given for the line to draw, therefore we can start it from anywhere. Let's start from this point and call this as point P. And now from this point, let's draw the slope, which is minus 3 over 7. If we write it as rise over run, rise over run, how much is the rise? The rise, if you compare, that is equal to minus 3. Minus 3 means that we are moving 3 units downward in the negative direction. So 1, 2, and 3, that's where we get. Here, if we go 3 units down, that's where we are. And now we are going for 7 units run. Because the run is positive, so we'll go toward right. So we will draw a line 1, 2, 3, 4, 5, 6, and 7. And this is where we end up by drawing the slope minus 3 over 7. Now, the line passing through point A and P is the required line. So we can estimate, if we had a ruler, we could draw the line. Otherwise, we can simply draw the line here. This would be the line passing through point A and continue to pass on the other side as well. So this would be the required line. And for question number 3, what is slope of x-axis? For question number 3, for any 2 points on x-axis, for any 2 points on x-axis, what is so special about points on x-axis? For any point on x-axis, y will always be equal to 0. So for any 2 points on x-axis, let's call first point A, and its coordinates could be taken as x0. And for point B, whatever its abscissa is, we can say y or equal y and then 0 as well. Abscissa, the vertical distance for both points on x-axis, is always 0. Therefore, if we write this as x1, y1, and write this as x2, y2, here what is x1? x1 is equal to x, and what is x2? x2 is equal to y, and what is y1? y1 here is equal to 0, and y2 here is equal to 0 as well. Therefore, if we draw the slope of x-axis is equal to y2 minus y1 over x2 minus x1. And because y2 and y1 are both 0, so whatever you have for the denominator, this is 0 minus 0 divided by y minus x. So the answer is always going to be 0, which means that slope of x-axis is equal to 0. And for any line which is horizontal or parallel to x-axis, the slope will always be equal to 0. And for third question, in fact that's fourth question, slope of y-axis. For the same reason, every point on y-axis will have its abscissa equal to 0. For any 2 points, on y-axis A, the abscissa is 0, and then let's call this as y1, and call another point B. Obviously its abscissa is again going to be 0, and the ordinate, let's call it y2. So this time if we take the slope is equal to y2 minus y1 over x2 minus x1, and you can see that y2 minus y1, which are in fact the values of both ordinates of points, and this is equal to y2 minus y1 over 0 minus 0. Because 0 minus 0 is again equal to 0, anything that y2 minus y1 divided by 0 is not defined. It's not a real number, it's undefined. We don't know what it is. Undefined. So the slope of y-axis is always undefined. We don't know what it is. And now the last question, slope of data in table. If we have data in the tabular form, question number will be 5. And if we have x-axis and y-axis, here we have values for x as 2, 4, 6, 8, and values of y are 3, 6, 9, and 12. This is a linear data. This is a data that is showing a straight line. There are 2 ways we can find the slope. Either we can write pairs x, y, and these pairs could be 2, 3, 4, 6, and 6, 9, and 8, 12, and draw these pairs of points on the grid and then find the slope as usual. Or what you can do is, here y is a response variable, or in other words, it is a dependent variable. You can take difference between two successive points. Let's take this difference. This is equal to plus 3. So while going from one point to the next point, the difference in the response variable or in the dependent variable's value is plus 3, and similarly the difference in independent variables values is plus 2 here. But remember, both should go in the same direction. So and here this plus 3 is a change in the value of y, and plus 2 is a change in the value of x. So x, the slope m could be equal to delta y over delta x. This is equal to plus 3 over plus 2. This is equal to slope of the data that is in the form of tabular data. And the last is the geometrical meanings of slope. Well, slope is very widely used in physics, engineering, medicine, everywhere, because y, the response variable, could be anything, and the independent variable x could be something. So this slope is in fact rate of change in y with respect to change in x. So this is rate of change of y per unit change in x. And if we are dealing with speed, velocity, that could be in the distance time graph, or it has many applications.